Playing with prime and composite numbers, let's talk about the least common multiple. So we abbreviate the least common multiple, LCM. So if you hear me say or somebody else say LCM, that's what we're talking about. There are two different ways you can find the LCM. The first is the list method. Second is the prime factors method. It really kind of depends on the numbers, which one is easier to use. We're going to do some examples of both of them. So when do we use the LCM? Generally when we're adding and subtracting fractions with different denominators, because we know to add and subtract fractions, you have to have common denominators, and so finding the least common multiple is helpful there. All right, let's jump in first with the list method. First, we're going to list the however many multiples of each number we need. We're going to find the smallest number that is common to both lists, and that's the least common multiple. We can do this. So we're going to start with 15 and 20, finding the least common multiple. So if I start out and say, okay, 15, what are my multiples of 15? Well, to find those, 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. 15 times 4, 15 times 5, 15 times 6. And this can go on as long as we need it to. Now let's go to 20. So I have 20, 40, 60, 80, 100. Again, I can go on as long as I need to. But hopefully, as you're looking through this, you notice we share 60. That is the smallest number in both, so we can easily see our least common multiple, 60. So you can see with numbers like 15 and 30, or excuse me, 15 and 20, it's not too bad to list out the numbers because it's not too bad. So in the list that's provided here, you see 120 is also a common multiple, but because 60 is smaller, it is called the least common multiple. If you're adding and subtracting fractions, you want small as possible to make your life easier. And so that's why we focus on the least part of this. Okay, let's go to the next one. 18 and 24, finding the least common multiple using the list method. Try this one on your own and then come back and see how we did. Okay, so 18 and 24. So I'm going to start and say, okay, 18 times 1, 18 times 2, 18 times 3, 18 times 4, 18 times 5. Okay, let's go 24 times 1, times 2, times 3. Oftentimes, as I'm doing the second number, and I always do the small one first, bigger number second, and then I can look and say, ooh, I can stop at 72 because there we go. So I know my least common multiple of 18 and 24 is 72. So if I go shove through this here, we can look through and easy to see that the lists are there. Now, those numbers that we've dealt with pretty so far, 15 and 20, 18 and 24, they've been fairly small numbers, not too ugly. So those are decent ones to use the list method. But what happens when we get uglier, bigger numbers? Well, that's where the prime factors method comes in. So first we're going to find the prime factorization of each number. So creating our factor trees. Once we have the prime factorization and we've written each number as a product of the primes, for each prime factor, we're going to use the highest exponent that appears. And I'll show you what this means in an example. And then we multiply those factors together to get the least common multiple. So let's jump in. 55 and 88 using the prime factors method. I'll tell you right now, I don't want to list out the multiples of this. Like I could get the times 2 and I wanted to think way too hard. So let's start with 55. Okay, so if I say 55, that breaks down 5 and 11. Easy when it comes to prime factorization because it's just the one pair. So I can write it as a product of its primes, 5 times 11. 88. Well, I see that 88 is 2 times 44. And then 44 is 2 times 22. And then 22 is 2 times 11. All right, so that gives me one. There are 3 2's, so 2 cubed times 11. So if you think about the base of the numbers that we have, in my 55, I have a 5 and an 11. And I have a 2 and an 11. So I need to have a 2, a 5, and an 11. So in my final answer, I have to have all 3 of these. And now we look at the exponents. A 2 is only in the second number, so I need the 2 to the third. We only have 1 5 over here, so that's taken care of. And you'll notice the 11 that is in each number is only 11 to the first power. It's just 111. So that's it. That's all we have. And therefore, this right here, 2 cubed times 5 times 11, is my least common multiple. And when you multiply those together, 8 times 5 times 11, we get an LCM of 440. Right? So that's the idea of the prime factors method, is that you break each one down and you see what they have. You need everything. So let's go on to the next one. Let's do 12 and 16. These are small numbers. You could do the listing method, not too bad, but we're going to do this with the prime factor method. Oh, wrong button. So let's go through and say, okay, if I have 12, well, 12 is 3 times 4. 4 is 2 times 2. So my prime factorization is 2 cubed times 3. Right? So that takes care of 12. Then I go to 16. Well, 16 is 4 times 4. And each 4 breaks down to be 2 times 2. Okay, so 16 is just 2 to the 4th power. Now, thinking through what we just talked about before, what are all of the base numbers? 2 and 3. So I definitely have like a 2 times 3. This one also has a 2. Now, since both of these have 2's, I compare them. Which one has the larger exponent? Well, that would be a 4. So I'm going to have 2 to the 4th power in my answer. The reason this works is because 12 only has 2 2's, right? And so I can take those 2's will fit inside of 16. 2 times 2 is 4. 4 fits into 16, so it's okay. It's already accounted for. So that's why we want the bigger exponent. So 2 to the 4th times 3, because here's the 1 3 right over here. So this is my least common multiple. Now 2 to the 4th is 16, and 16 times 3 is 48. You can always go back and check, right? Your least common multiple will be bigger than your numbers. So because 12 and 16, they don't fit into each other, they both go into 48 evenly. 48 is our least common multiple. So looking at the work here, again, you want to break down to the prime factorization, the highest exponent for each factor, multiply those together, and you get your least common multiple.